Okay, David I here, and I'm going to show you a little bit about the C++ 11 support that's now included in C++ Builder 10 Seattle. It allows you to use the C++ 11 language on Win32, Win64, iOS, and Android. So C++ Builder 10 Seattle allows you to use VCL and FireMonkey applications, build those for Windows 10, for VCL and FireMonkey, access the Windows platform APIs for Windows 10, and with our new Clang enhanced RAD C++ compiler for 32-bit Windows, you can use the same C++ 11 language for Win32, Win64, iOS, and Android. We still have our classic C++ compiler for Win32 and OS 10 for your existing projects. The IDE is large memory model, which means your C++ projects and project groups, you can have very large projects in memory and be able to work with them. We've also enhanced, as you've seen in some of the other sessions, the IDE capabilities. We also, if you're using a Clang-based compiler, you can do parallel compilation for as many cores as you have in your system for even higher speed builds. This is just a look at the C++ compilers and the platforms that go along with them. BCC32C is the new Clang enhanced C++ compiler for 32-bit Windows. That's based on Clang version 3.3, same as our BCC64 compiler, Clang 3.3, BCC iOS ARM, ARM64, and Android ARM use their versions of Clang as well. For libraries, we have the Dinkomware standard library for C++ for Windows and OS 10, version 6.5 for BCC64 and the 32-bit Clang enhanced compiler, and version 5.01 for BCC32 and BCC OS 10. We use the standard library for iOS that's included in the iOS SDK, and we use the standard library that's included in the SDK NDK for Android. We also have Boost support for Windows. For the Windows Classic compiler, we use Boost version 1.39. For the Clang enhanced compilers for Win32 and Win64, we use the Boost version 1.55. It's easy to switch for Win32 C++ using the Classic compiler or the C++ 11 compiler. There's an option in the project options C++ compiler under Classic compiler. If you set that to false, it'll use the Clang enhanced compiler. If you set that option to true, and it's true by default, it'll use the Classic compiler. So if you want to use the full C++ 11 language that we support, just turn off the use Classic compiler in your existing projects. If you say file new, a Win32, whether it's a VCL or a FireMonkey project that you're creating, and you want to use the full C++ 11 language, go in first thing and say target options, use Classic compiler, and turn that to false, and you'll be just fine. So here I want to do a few demonstrations of some simple applications to show using the IDE, both for Win32, Win64, and I've updated my iPhone 6 to now use iOS 9, and I've updated my Xcode to have Xcode 7 so that I can do development of my iOS applications. We're still using the functionality that was in RAD Studio and C++ Builder 10 Seattle for iOS APIs that we have. You can always use the Objective-C bridge to make calls into the API and the frameworks for iOS 9. But all the applications you build for 32 and 64-bit will run fine, built with C++ Builder 10 Seattle. I'm going to switch over to the IDE, and in my IDE, I have a favorites project group here with just two C++ 11 projects. So this first one I just call Lambda Demo. Let's go and open up its source code. It's got a single button in the user interface, and on the button click handler, I'm using an auto and setting this Lambda, this pointer, that's the capture variable that I'm using so that I can get to the label 1. So let's first go up here and set Win32, and I'll go and say project options, compiler, and here you'll see use Classic Borland compiler. I've turned it off. If I turned it on and did a build, it would complain about this language syntax because we didn't have support for lambdas in the Classic compiler, but I'll leave it off. So I'll just take this first simple project and I'll run it on Win32 and see that I can now use C++ 11 language capabilities on Win32. So it compiles and links, and there's a Win32 using a C++ lambda. I'll also go to my iOS device and we'll set its target, compile and run this example. 64-bit, there's the splash screen. Here's the example. I'll click on the button, lambda, 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 and it gets the code within a lambda expression put in the labels text property. We'll switch back to a second example. in the IDE. This one is using the parallel programming library that's part of the system threading unit. And here I've got the task run method, and I've got a lambda embedded inside the task run method call, again capturing the this pointer so that I could output information to the form. And then I've got an embedded lambda as well to do a thread synchronize so that I could add to the memo lines that's in the user interface. I've got two buttons, one that starts the task and a second button that will just display the current value of the variable value. So we'll go and compile this second example for 32-bit Windows. So we'll start the background task and we'll show the value, and the lambda is working away, and I can look at the current value that's being updated in the task. It's finally done. Let's compile for 64-bit Windows. And again, the background task, look at the values. It's doing a sleep and doing its work till finally the background task is done. Then finally, let's go and select iOS device 64-bit. So I'll go and compile and run this. There's the splash screen, and I can click on the background task button and start showing the value by tapping on the second button until the task is complete and everything's done. So just to summarize this section, C++ 11 on Win32, Win64, iOS 32, 64, and Android. Full large memory model IDE for project power and productivity and scalability. Fastest way to build, your data-rich applications on Windows 10, Mac mobile, work with the Internet of Things, devices, sensors, and so on and more. C++ Builder VCL and FireMonkey development. And for new C++ mobile and desktop developers coming from other languages and tool sets, you have a C++ 11 development environment for Windows and iOS and Android. What parts of C++ 11 are not supported in C++ Builder yet? We have a page which is the C++ 11 status. So the other way to look at it is since we build our compilers by using Clang and adding all of our compiler work and our language extensions and so on, we map to what's going on also in the different versions of the Clang work that's part of the LLVM project. So for Curtis, I'm going to put the link in here, which is the link to our status page for compliance, and it's right here. So the C++ language features, you'll notice this is our classic compiler, a BCC32 column where we had a few things that we had done, auto-type variables. We used to call that C++ 0x years ago. And then here's the BCC32C where it goes down. So if I scroll down, let's see, standardized attributes index, alignment support, inheriting constructors. Just a couple things down here, I think, in the concurrency that are still being worked on. Memory models in the concurrency area, but everything else, thread local storage. So, but we'll continue. The Clang work continues both here as well as in the committee. So there's always more that's going to be done in the world of C++ 11. And then C++ 14 was a maintenance update kind of release of the language standard. The real work and new work is coming out in what's called C++ 17. So we go to the committee meetings. We're members of the C++ committee here at Embarcadero. We also go to the Clang and LLVM meetings that happen in the Silicon Valley, and Google and Apple and a bunch of other people are involved in that effort to move these technologies forward. Even Delphi, for some of the platforms, uses the back end, the same back end that we use for doing optimizations and code generation for ARM chips and so on.